And let me see, the first lightning talk is from Fei Wang. Fei.
Oh, hi. Let me share my screen. I'm Fei. Hello?
Just checking that we can all see.
Okay, good. Yes, hello, I'm Fei. I'm from the University of Alberta. Today I'm talking about how to build a domain-specific ESI-MS prediction models from a pre-trained CMID 4.0. So quick recap, what's the CMID 4.0? Last year we released the fourth version of the CMID model. It's basically it's a machine learning models can do compound to MS model predictions. And for the mainly aiming for the metabolomics data. It was trained on the methylene data set, which is consistent of around 4,000 MS to compound MS to pairs. What we have learned is it's very hard to covering this very complicated and a large chemical space consisting of all the metabolites. There is then later in the last year, there was a group from Denmark approached us, was asking us the question whether it's possible we can build a domain-specific models to cover a specific set of the compounds, because they are a forensic lab or they're really interested in particularly illegal drugs. So here we presented this workflow to build this domain-specific set of things. So basically, the CMID 4.0 is using a deep neural net combined with a set of another techniques. And one of those known techniques for the deep neural net is you can do transfer learning. The idea is just in the training time, grab an already existing model. You freeze a bunch of parameters, only upload the last few in the last layer. So as here we showed, we grabbed a CF94 model, which is we published now public available. Then we input the training process with the whole set of domain-specific MS22 compound pairs. In this particular case, we did 390 MS spectra. 319 compounds and their corresponding spectra from a database or data source. After a short time training, because we got a specific models only aiming to cover the compounds in this particular chemical class. Well, let's see how the performance goes. So here's the performance we compare crossing the old CMID3 and the newer CMID4 and our domain-specific models on the holdout dataset. This is holdout dataset have a size of 120 compounds in there. As we can see here, although the CMID4 is a good leap from the CMID3 on average, both in terms of dice coefficients and dot product, the domain-specific models are almost doubled both measurements on in terms of predicted spectral qualities. And the training process is super fast since the pre-trained CMID models giving already did the heavy lifting of the extracting information from raw data. So the stats aside, I would throw a random pick results from in a classification scenario. Where we showed the comparison between, on the left side, we showed the comparison between the MS2 data. As we can see, this CMID is doing an okay-ish job, but however, is definitely predicting a lot of not supposed to be their picks. On the middle, we have our newly trained domain-specific models is doing a great job, basically nailed every single pick supposed to be in there with a little bit of noise over here. And in terms of the usefulness of our predicted spectra, we presented here as this is done identifications using PubChem. The CMID doesn't really need to do anything similar to our target structure, and our domain-specific models are doing much better. So This is everything I want to share today.
Okay.